Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In electrophilic aromatic substitution, EAS, halogens are ortho-para directors due to lone pair donation into the ring. However, the OP ratio depends on the steric and electronic factors of the halogen substituent. Moving on to the next step. All halogens, F, Cl, Br, I, are ortho-para directors via resonance donation of lone pairs. However, the effectiveness of resonance donation varies with the size and electronegativity of the halogen. Moving on to the next step. As the halogen gets larger, FCl-Bri, the steric bulk at the ortho position increases, which disfavors ortho attack relative to para attack. Larger halogens create more steric hindrance at the ortho positions, thus lowering the OP ratio. And for the final step, fluorine is the smallest halogen with the least steric bulk. Despite being highly electronegative, which weakens its resonance donation, its small size means ortho positions are least sterically hindered. The OP ratio is highest for PHF because steric hindrance is minimal at ortho positions. As we go from F to Cl to Br to I, the size of the halogen increases, leading to progressively greater steric hindrance at the ortho positions. This results in a decreasing OP ratio in the order PHF, PHCl, PHBr, Phi, I, ABCD. Therefore, the correct order of OP ratio is DCBA, which corresponds to option C. Wait, the given answer is A, which is option ABCD. Let me reconsider. The OP ratio can also be influenced by the inductive effect. As electronegativity decreases from F to I, the inductive withdrawal decreases. More electronegative halogens, F, withdraw electrons more strongly by induction, which disfavors the already electron-poor ipso and ortho positions differently. Additionally, the stronger the inductive withdrawal, the more it deactivates ortho positions relative to para, since para is farther from the withdrawing group. So stronger inductive withdrawal, F, leads to a relatively lower OP ratio because ortho is more deactivated inductively than para. From F to I, inductive withdrawal decreases, so ortho attack becomes more favorable relative to para, increasing the OP ratio in the order FCl-Bri, I, ABCD. ABCD. The dominant factor determining OP ratio here is the inductive effect. F has the strongest inductive electron withdrawal which relatively deactivates ortho more than para, giving the lowest OP ratio for PHF. As we go to I, inductive withdrawal is least, so OP ratio is highest. Why other options fail? Option B, A is equal to B is equal to C is equal to D is wrong, halogens differ in their effects. Option C, DCBA is wrong, this would be the order if steric effect alone dominated, but inductive effect is the primary factor here. Option D, DBAC is wrong, it gives no consistent trend. Therefore, the correct answer is A. Therefore, the correct answer is option A.